Hello everyone. In this video, we will explain a few examples based on the properties of SURDS. So before I explain a few examples on SURDS, I will let you know one point that if A is greater than or equal to 0, right, then we write root over A square equal to, we write directly. In fact, root over A square. In fact, we write that modulus of A, which is never negative. Further, if you want to open this modulus, you write A as it is. If we know that A is greater than 0, we write 0 if A equal to 0. If we know that A is negative, then we write minus A if A is less than 0. So particularly this root over A square equal to writing mod A is very, very important. Remember that if you write root over A square equal to A, it is always wrong, because root A square is never negative. Root over A square is always greater than or equal to 0. It is never negative. Okay, let me explain a few examples. Let A comma B greater than or equal to 0. Right? Then root A plus root B whole square equal to. Okay. We just expand using algebraic identities. This gives us root A whole square is nothing but A plus 2 into root A into root B plus root B whole square equal to B. So here I'll write that root A whole square equal to root A whole square equal to, it is A, where of course A is greater than or equal to 0. And root over AB equal to, we write root over mod A into root over mod B, provided AB is greater than or equal to 0. This has to be defined. So therefore, this implies root A plus root B whole square equal to, we write that A plus B plus 2 root AB. See, now here the process is, how do we express that RHS1? So now my point is, what is root over A plus B plus 2 into root over A into B? How do we write this? This is the important. See here, one 2 must be there. That inside this root, A into B is there. Here we have sum of these two quantities. Then this is equal to taking square root both sides. So this is nothing but root over. Here you see that root A plus root B whole square. This is equal to, as I told you, that we have to write modulus of root A plus root B. But anyway, this quantity is always greater than or equal to 0. Here you see, mod A equal to, we write A without modulus if A is greater than 0. So this we write directly root A plus root B. This is a very important. Many students may feel difficult in finding square root of a surd. So therefore, we can write that root over A plus B plus 2 root AB equal to. Now we can write directly root A plus root. Okay. So here you see sum of these A into B, that sum has to be here. For example, I'll give you an example. What is root over 4 plus 2 root 3? What is root over 4 plus 2 root 3? So here the point here you see that we must have a 2 here. So 2 is there. Now the point is 2 into that inside the root, this 3 has to be written as product of two numbers in such a way that their sum is a 4. Their sum is a 4. So now I can write here 3 plus. So directly now we can write this is root 3 plus root 1. Root 1 is nothing but only 1. So this gives us simply root 3 plus 1. Very quiet and simple example I have given. In this way, you must be able to express that given surd as A plus B plus root over A into B. If you want, I'll give you another example. Here you see that root over, okay, root over 2 plus root 3. This is a quite little bit different as compared to the previous one. Here we must have a 2. Observe here, we have a 2. But we don't have anything here. Well, so for that what we have to do, root over 2 plus. So I have to multiply 2 and divide by 2. So this I can write 2 by 2 into root 3. Further, this is equal to root over. I can write 2 plus, leave that numerator 2 here and bring inside this 1 by 2. When it's going inside the root, it becomes 1 by 2 square. Okay? Because here you see root over A square into B. I can write this as A into root B. Of course, where A is positive or greater than or equal to. So when this A going inside, it becomes A square. It becomes A square. So now you see this is equal to root over 2 plus, I can write 2 into under root. Here this is 3 by 4. I can write 3 by 2 into 1 by 2. So what is the sum of these two? Sum of these two numbers is 2. So therefore, further we can write this is root over 3 by 2. Root over 3 by 2. Okay, or I can write this is root over 3 by 2 whole square plus root over 1 by 2 whole square. Nothing but the sum is 2 plus 2 into root over 3 by 2 into 1 by 2. So it is in the form of a square plus b square plus 2ab. It is in the form of a square plus b square plus 2a. So I can write this as root over 3 by 2 plus root over 1 by 2 whole square. This further gives root over 3 by 2 plus root over 1 by 2. That's it. So this is equal to root 3 plus 1 by root. So these are the very important in to understand the further mathematics. So without learning this, you can't find good mathematics. Now we have seen that root over a plus b plus 2 into root ab equal to root a plus root b. This is a very important. The second one is what will happen if you take the difference? Root over a plus b minus 2 root a. Okay. So now this is nothing but root over this a I can write root a whole square. B I can write root b whole square minus 2 into anyway a and b are positive. So root a into root. This is equal to, this is in the form of x square plus y square minus 2x. So I can write root a minus root b whole square. Well, use the above fact that root over x square equal to mod x. You write this. So this is nothing but modulus of root a minus root b. Remember, this modulus is always greater than or equal to 0, and this root value is always greater than or equal to 0. It is never negative. I'll give an example. For instance, that root over, what is that root over? 5 plus 2 root 6. 5 minus 2 root 6. 5 minus 2 root 6. So this is equal to 6 root over 5 minus 2 into this root over 6 I can write 3 into 2. Well, so the sum is 5. Sum of these two numbers is 5. So now I can write that this as 3 plus 2 minus 2 into root over 3 into 2. So it is exactly same as of the second point, root over a plus b minus 2 root ab equal to modulus of root a minus root. Don't write directly root a minus root b. You must keep modulus. So now this gives us modulus of root 3 minus root 2. Now we have to open the modulus. See, this value is never negative. Now, which is larger? This root 3 is greater than root 2. So now you can write this is equal to root 3 minus 2. You write always bigger one, after that smaller one. So this is the bigger one and this is the smaller one. Well, I'll give you another example based on this difference. Well, here is another example. Root over 12 minus root over 140. So we must have a 2 here beside this inner root. So for that, what we have to do is 12 minus root over, you have to express this as 4 into something to bring out 2 outside. So 4 into, it is 35. So this is equal to, now we can write 12 minus root 4 is 2. So this is 2 into root over this 35. I can write 7 into 5. So the sum of these two numbers equal to 12. Here is the 12. So therefore, this is nothing but root over 7 plus 5 minus 2 root over 7 into 5. So this is root over a plus b minus 2 root ab. So we can write that difference of root 7 minus root 5. You open the modulus, write always the bigger one. The bigger one is root 7. So this is root 7 minus root 5. So this part is over. So in this way, you must practice as many questions as you can. The third one is, well, root a plus root b plus root c whole square. We know that x plus y plus z whole square from algebraic identities. So I can write directly here, root a whole square is nothing but a plus root b whole square b plus root c whole square, it is c, plus 2 root ab, 2 into root b into root c, plus 2 into root over ac, where a, b, c are all greater than or equal to 0. So now, therefore, what we can write, the RHS expression equal to root over a plus b plus c plus 2 root ab, a into b, plus 2 into root over b into c, plus 2 into root over a into c. This is equal to, we can write that root a plus root b plus root c. Because it is greater than or equal to 0, it is greater than or equal to 0, it is greater than or equal to 0. Therefore, totally it is greater than or equal to 0. So no need to put any modulus. The modulus will occur when we use difference of two quantities. So this expression is also very, very important. I'll write one example based on this fact. Well, here is an example. Root over 9 plus 2 into 1 plus root 3 into 1 plus root 7 equal to root a plus root b plus root c. Then what is a plus b plus c value? Okay. So we have to express the given problem as root over a plus b plus c plus 2 root ab plus 2 root bc plus 2 root ac. Good. So here the solution is that given expression 9 plus 2 into 1 plus root 3 into 1 plus root 7. We have to expand this. We have to multiply term by term. So 9 plus 2 into, first you multiply 1 into 1, so that becomes 1. Again 1 into root 7, that becomes root 7. Now start with the root 3. Root 3 into 1 is root 3 plus root 3 into root 7. Root 3 into root 7. So this is equal to, okay. So here I'll write that first of all 2 into root 7. Nothing is there. So I'll write 2 into root over 7 into 1 plus 2 into root 3. I will write 3 into 1 plus 2 into root over 3 into 7. So comparing with this, here you see. So assume this is A, right? This is B, and this is A, and you call this as a C. Now this is B, and this is C. So what is A plus B plus C value? Here A plus B plus C value is 1 plus 7 plus 3, 11. Here 1, 2 is there, 9 is there. It is totally 11. So I can write here 1 plus 3 plus 7. It is exactly same as of above one. This is A, and this is B, and this is C. So now we can write this as, this is equal to root 1 plus root 3 plus root 7. That's it. So therefore, A plus B plus C equal to, we got that 1 plus 3 plus 7 equal to 11. In this way, we can solve many questions based on these rules. Based on these rules. So one little tough question is here. Simplify the expression root over 2 plus root over minus 2 plus 2 root 5 minus root over 2 minus under root minus 2 plus 2 root 5. Well, how do we approach to simplify this expression? For this, you just square it. So that is the main idea. So m square equal to, assume this as A, okay, assume this as B. So m square is nothing but root A minus root B whole square. This is nothing but A plus B minus 2 root AB. What is A plus B here? Adding these two, A plus B is here, that A plus B equal to, say this term will be cancelled, so you will get 4. What is A into B? A into B is nothing but 2 plus under root minus 2 plus 2 root 5 into 2 minus under root minus 2 plus 2 root 5. Now this is x plus y into x minus y. This is x, this is y, this is x, this is y. So x plus y into x minus y equal to x square minus y square. Now I can write x square is nothing but 4 minus y square is nothing but minus 2 plus 2 root 5. So on simplification, 4 minus of minus 2, 6 minus 2 root 5. So everything we'll write here. A plus B is 4. 4 minus 2 times of what is AB? AB is 6 minus 2 root 5. So root over 6 minus 2 root 5. Well, so further we have to simplify this expression as this minus 2 into root over 5. I can write 5 into 1. So that this sum is 6. We have to express this 5 such that sum is 6. So this I can write 5 plus 1. Well, so now it is root 5 minus root 1 whole square. So 5 minus 2 into this is root 5 minus root 1 whole square and under root. This is equal to 4 minus 2 times of, you have to write modulus of root 5 minus root 1 is nothing but 1. Because root over a square equal to mod a. So first you write that bigger one. Here this root 5 is bigger. I can write root 5 minus equal to 4 minus of minus here plus 2, 6 minus 2 root 5. So this is m square. But we want m. Well, so therefore, this implies m equal to root over 6 minus root 5. Already we did that. Root over 6 minus 2 root 5 value is root 5 minus 1. So this is equal to root 5 minus. That's it. So in this way, you can solve many questions. Consider one more example. Root over 17 plus 4 root 13 minus root over 17 minus 4 root 13. Well, if we do one expression, automatically the other expression can be obtained just by taking the difference. So here, root over 17 plus, here you see 4 root 13 is there. Inside the root, we must have only 1, 2 as a multiplied. So keep 1, 2 here, send another 2. This 4 is 2 into 2. Keep 1, 2 here and send another 2 inside the root so that you will get 13 into 4. Only one line. Now 13 plus 4, this sum equal to 17. So directly you write that it is root 13 plus root 4 or root 13 plus 2. Now what happens when negative sign is there between these two quantities, right? So instead of this summation, you have to write difference, but you must always write that bigger value first, after that minus to smaller value. Now adding these two together, just adding these two together, you will get answer is 4. So the answer is 4.